this a function?
No.
No. What makes it not a function? 7 versus everything. Everyone should be paying attention. For number 2, you needed to evaluate this. Put -4 in for all of your x's. This would become a -64, but there was a negative on the outside already. So this would become +64 minus 48. So 16. The range of number 3, you're looking lowest to highest. These are endpoints. So if you did it in interval notation, there should be brackets, square brackets, from -2 to +5. Or in set builder notation, because this is range, we need y. And then -2 is less than or equal to y, which is less than or equal to 5. Yes. More than likely the set builder notation, because interval notation is a advanced concept.
Yes. Yes.
Wait, are we talking about like the bracket part isn't going to be on the test, or this would be?
The bracket part. No, it's the bracket part that you
Yeah, that's the easy one.
I know.
I don't know how to do it.
Yes.
But the set builder is something we've already talked about. Or was combining like terms. So you needed to distribute everything. So you get 8x minus 12 minus 6x minus 12 plus 3x minus 12. Combine all your x's together. 5x minus 36. And combine all your 12s. Questions on any of those 4? Number 5 on the back. There were a few different ways you could go about doing this. You could graph those points and find the slope from that. It gives you your y-intercept, so you could easily put together your so that would be a 0, 3, and slope here would be -1/2. So your equation would be -1/2 x plus 3. You could have also found your slope algebraically and then realized that they gave you your y-intercept and put that in. You could have also put in one of the points into your point slope formula and use that to find your equation. Any of those would have worked. Questions on that one? Yeah, we are now going to go over the SOL A.5d, A680. For A.5d, this is systems of inequalities. Almost all of these could have been done in desmos because it'll graph it for you. For the ones where you actually have to graph, you would have needed to copy that graph onto here. I have more. Oh my god. That's embarrassing. That's embarrassing.
I'm not sure. And I'm like behind you, Chad. Almost twice.
Right, so starting with number 7, I put these you could have put these directly in desmos or solved them algebraically, either or. And then graph this. This would have been a solid line shaded above. And this would have also been a solid line shaded above. Part A wanted you to write 2 points that were in the solution set. That could have been any 2 points. So yours don't have to match mine. Part B asked for the points that are in the solution set. One for certain that was in there was -4, 4. -4, 2 fell on the outside. So that should have worked, but just to double check, I put that in, and it did work. This 4, 4 did not work because that was outside of it. So just those 2 solutions.
Wait, what page is this?
I don't think there are page numbers on it. But it's SOL A.5d.
5D?
5. 5d. Question on that one. If we need to see any of these in desmos, let me know. Number 8, again, you could have put these in desmos, have them graph it, and then put these points in, see which ones fell in the shaded area, or which ones didn't. There were obvious ones that fell in, and there were these 3. This one fell like on the outside, so to double check that that worked, put that in for all of your x and y's, and that did work for both, so that one was also a solution. Questions on each? 9 was the same thing. Put these 2 into desmos. There were ones that were solutions. You could visibly see it. I think it was this one. No. This one was definitely one you could see, and this one was definitely one to see. The other 2 fell on the outside, so I checked those, and they both worked. So you ended up with 4 solutions there. 10, there was only one answer that was correct. If you put these into desmos, only this one fell in the shaded area. Do we need to see any of those? Moving on to SOL A.5d. That is all about slope, finding slope. So these could be done algebraically or graphically on desmos. Algebraically, you will need to solve it, get it in slope-intercept form, and find the slope. So -3/2, +4/3, and 2 were your slopes for those 3. If you did it on desmos, you could put in the equation given and count your slope on the graph. Number 2, you could do this algebraically or in desmos. Algebraically, you would do your y2 minus y1 over x2 minus x1, get 1/2. Graphically, you would have to plot both of these points and count the slope. Same thing with number 3, you can do it algebraically and get 1. However, you would need to know that an x-intercept is written in the format 4, 0. And then if you're graphing it, you would also need to know that so that you could plot both points and count the slope. And then for number 4, same thing, you could do it algebraically and get -2, or put that into desmos and count your slope. Anyone need to see any of those in desmos? Number 5 was another one you could have done either way and gotten -4. 6, you would have had to know that an x-intercept is written as 5, 0, y-intercept is written as 0, 3. You can find the slope algebraically or put those in, count the slope. Anyone want to see either of those in Desmos? Six B was graphing/writing. So you could do this algebraically or in Desmos, either or. So algebraically, you would need to solve this, put it in slope-intercept form, and graph at least 2 points, the y-intercept and one of your slope points. That would give you 2 points. If you did this on Desmos, put this in, it would show you your line, and you would just need to take 2 points from that line. Same thing with number 8. You can do this algebraically. Find your y-intercept and or your slope-intercept forms. Start plotting those 2 points, your y-intercept, and at least one other slope point. Doesn't have to be this one, it could be another one. Or put it into Desmos and plot at least 2 points. And we need to see either of those in Desmos. Nine and 10 were similar. So you could have done this a couple different ways. If you started off by graphing it, you would have to know that your x-intercept is written as 3, 0. And then you need to plot both points, find your graph, or find your slope, and then go from there. You could find it algebraically, find your slope algebraically, and then use your point slope with one of the points they gave you to find your y-intercept. You could also put it in Desmos and do the same thing. So our final answer that they're looking for is the equation of the line y equals -2x plus 6 and this graph. Ten is similar, except now they give us our y-intercept instead of an x-intercept. Again, you could rewrite this as an ordered pair, find your slope, and then go straight into your slope-intercept form. Or you could plot both points and find your slope and go from there. But your equation was y equals 4 over 5x minus 3. Questions on either of those, or do we need to see either of those in Desmos? This is one. Number 11 was similar to one of the questions we already did, where they give us the x-intercept of 5, y-intercept of 3, find the slope, but then they're asking for the equation of this line. So once we have that slope, they give us a y-intercept, we can put that together to make our slope-intercept form. You could also plot the 2 points they give you, count your slope, and then write the equation of your line on from Desmos. 12, however, is something new. So we talked about parallel perpendicular lines before, how to find them, but we didn't do it to this extent. I don't believe. So with this, we're kind of doing the same thing. We're given some point, and we're given a line, and they tell us we want to find another line that is parallel to the one they gave us. So to figure that out, we have to know a couple things. Parallel means that it would have the same slope. So doing this algebraically, we would need to take the point they give us and the slope that would be the same and put it into this format. The arrow's not part of that format. Where we solved to get our new y-intercept. This, I think the point they gave us was incorrect because we ended up getting the exact same line, and I like triple checked it, and we shouldn't have, but that would be how you do it. Or you could do this on desmos. You would have to graph this line, know that parallel means same slope, plot this point, and then count using that slope from this point to find your new y-intercept.
Can you show us that?
Yeah. What was that we were saying? So the line is plotted, the line is graphed, the point is plotted. This point is already on this line. That's how we know something's off. But in a usual situation, they wouldn't touch if they're parallel. So you would look at this point, find the slope of this line, which is 2. Since it's parallel, it has to be the same. And you would take that same slope and find that y-intercept, which would be, and write that equation. If it were something different, so let's change this. Now, if the slope was 3 and it has to go through this point, I would go up 1, 2, 3 to the right one, and now my slope would be 3, but my y-intercept would be 5. And my equation would be y equals 3x plus 5 instead. This is my original equation, but my new equation would be that one I just said. So some of that you would need to know, but then others you could find from using the. The next couple of questions are similar. So 13 is now perpendicular, but doing the same thing. So algebraically, you would need to know that perpendicular means negative reciprocal slopes. So you would find the slope of this line and make it flip it and make it a negative if it was positive and vice versa. So our new slope would be negative 1/4. Then we would take that point and that slope and put it into our point slope formula and solve. Or in desmos, we would graph this line, find our new slope, plot this point, and then from this point, use this slope to find our new y-intercept. Does anyone need to see that one? Yeah. 4x plus 6, 14. So we have our line, we have our point. The slope of this is 4, but we need the negative reciprocal, so that would be negative 1/4. So from this point, I would go up 1 to the left 4, and I would end up at 9. So I would use that slope of negative 1/4 and my point of 9 and write my equation. Negative 1/4 times 4 is 9.
Oh, so basically, I thought that you were supposed to like graph maybe 1 to 2 as well. Everything else is do that.
Yeah, so you could, but you would have to put in the equation. Really, it's just counting from whatever point. 14 and 15 are similar, except these equations they give you are not in SOL-A.5d form, so you need to solve that first, and then the process is the same. So this one is parallel, so you need same slope, so slope of 3. And algebraically, take that slope of 3, take that point, put it in, solve for y. Graphically, take this equation, take this point and count a slope of 3 until you get your y-intercept. 16 is the same, but it's perpendicular. So solve this equation first. Find your new slope. So this is -5. You take it, flip it, and make it positive. Algebraically, you would take this slope, this point, put it in, tell me your y-intercept. Graphically, you would take this equation, this point, and from this point, use your new slope to find your y-intercept. Do we need to see either one of those in Desmos or have questions on those? The next objectives that are due next Thursday for you guys, I think, because I see you, what's today? Friday? So Friday, never mind. For Friday, the next ones that are due are A6C, A7A through D. Yes, please.
On the SOL there, are we taking it in more here and now?
11:20. So A6C, A7A through D. Yeah.
The one that we're learning today, it's going to last 1 hour. Well, I think we still have it more than
We still have other things we have to learn. Before we start our notes for today, do we have any Khan Academy just math questions that we wanted to ask, go over, had a question about? Did I add new Khan Academies? Yes. There were the 2 on dividing polynomials that were already due this Friday. And then the drafting stuff from last class that we did are also due today. The stuff we do today is due next Friday. We may not. The more questions you ask, the less SOL review we'll have time to do at the end, so that depends. No, you can go to the bathroom and go grab some. So at the end of notes today, we'll be doing SOL review. The longer it takes to do the notes, the less time we have to do SOL review. I would rather we have more time to do that. Not saying don't ask questions, but we'll hold questions until the end of the problem. So everyone should have this on their desk. And then Kaden, go back to your seat. Theo, go back to your seat. Not right now, maybe later. It's something we've already talked about, just here's an additional step to it. So last class we did a bunch of stuff with quadratics on axis of symmetry, vertex, domain, range, solutions. And we were able to find those solutions from a graph wherever it crossed the x-axis. Now we're going to be doing that same thing, finding solutions, but algebraically. There are different ways to find it algebraically. We're only going to be finding one. So with this, you'll have something that you need to factor. We're going to mess up. And your equation needs to be equal to 0. If it's not, we would need to solve it so that it's equal to 0. If it already is, we can skip that step. it says factor the left side, but it's really whichever side needs factor that side. Then once we factor everything and we end up with the factors at the end, we're going to set each factor equal to 0 and solve. And that's going to give us our solutions. So one, we need to remember how to factor and the different ways we can. Remember that GCF you can really do to any set of terms, any number of terms. But if you have 2 terms, you're either looking for GCF or difference of squares. If you have 3 terms, GCF is always an option, but there's also factoring trinomials when A equals 1 and factoring trinomials when A does not equal 1. And then 4 terms would be grouping, but really you'll just see the 3 terms. So with this, there's only one way, 1 or 2 ways we could graph this or factor this. This has a 1 in front, so it's going to be factoring trinomials when A equals 1. So what are we looking for? When we factor this? We're looking for a rule. That X thing, yes, but not the axis of symmetry thing. So we're looking for 2 numbers that.
Oh, that multiply, add, multiply
Not multiply before.
Add.
1 times 3.
Add to be 4, but multiply to be 3. And 1 and 3 would work. With trinomials, where A is 1, you can go directly into your factors. So x plus 1, x plus 3. And make sure to set this equal to 0. Once we have those factors, you can set each factor equal to 0 individually, and you can drop the parentheses. So we have x plus 1 equals 0 and x plus 3 equals 0. And then you would solve. You guys close it? How would we solve this? So that would give us x equals -1 and x equals -3. So if your factor is written with an x and it's plus some number or x minus some number, your solution will always be opposite, yes. If there's a number in front of x, it's a little different. But we'll get to some of those here in a bit. So if you see that, if I see x plus 1, I know my solution is going to be -1, and vice versa. You don't have to solve it. You could go straight into x equals -1, x equals -3. We do have to write this a certain way, though. We're writing our solutions as a set of numbers, so we're going to write -3, -1. Most of the time, you'll see this least to greatest, so that's how I'm going to write it also. This one?
Yeah.
Remember that after we find these 2 numbers, these 2 disappear.
You have to go from these to greatest and then to the bracket.
I would say yes, because that's how you'll see it. So that would be our answer, yep. Do we have any questions on any of that? We're going to jump around. Number 4, would we solve that or factor that similarly to number 1? Yes, because there's a 1 in front of square, so it's going to be solved the same way, or factored the same way. We're looking for what? What about those? Also to be -27. What 2 numbers would work? 9 and negative 3, yes. So our factors would be x plus 9, x minus 3, and then what would our solutions be? If they're always opposite. Negative 9 and positive 3. And that would be our answer.
So we could skip the steps.
Skip the solving step.
Yeah.
For now, I'll show you, or when we get to something where you need to solve it, we'll get to that here shortly. Question on that one? Get down to number 9. How could we factor this? In this case, we don't have, we can't think of two numbers. The process isn't the same. We have two terms. If we have two terms, how can we factor it? So your GCF would be x, and then x minus 8, yes. So when you factor out a GCF, you are still going to set whatever these factors are. This is a factor, even though we took it out, equal to 0. But what's nice about that is it kind of solves itself. We don't have to do anything to it. What would the solution for x minus 8 be? Positive 8, so our solutions would be 0 and 8. Questions on that before we continue, CK?
Do you have to put the curly brackets?
Yes. That tells you these are your solutions. Number 10, how would we factor this? So this one is also GCF. It's not difference of squares, which is the other way that they factor two terms, because neither of these are perfect squares. So if we factor out 3x, x plus 5 is left, then we would take both factors, set them equal to 0. We divide it by 3. I should have done that for this one too. Still set this equal to 0, but you don't have to actually solve it if you know it's the opposite. So with this one, we would need to divide both sides by 3, but we would still get 0. And this one would become negative. So our solutions would be negative 5 and 0. Questions on that one? Anyone still need that? Priscilla, do you still need that? On the next page, we're going to do number 14 and 16. How could we factor 14? Say that one more time. X minus 5 plus 5, because this is the difference of squares. If we set both equal to 0, what would our solutions be? Negative 5 and 5. So when you write these solutions, there are two different ways you could write them. I'm going to show you both. One, you could write it just as we have been, negative 5, 5. Or, since they're the same number, but just one is positive, one is negative, we could write it as plus minus. It's like a combined symbol, but. So,
What do you mean you said it was a like how is it?
this does not have a GCF. And 25 and x squared are both perfect square terms. For 16, how would we factor that? Difference of squares again, so 3x
minus 7.
minus 7, and set both factors equal to 0. This is a case where I would solve at least one of them, because the other one's just going to be the opposite, positive or negative, or whatever you have. So solve one of them. We add 7 and then divide by 3. We have x equals positive 7/3, which means the other answer would be negative 7/3. Our solution would be positive, negative. It's really a plus minus symbol, is what it's called. 7/3. What questions do you have on that one? We're going to jump down to number 20. If you have something that's not in standard form where it's not equal to 0, you will need to get everything to the same side. I would say whichever side the x squared is on, move everything to that side. So when we do this, we would move 4x over by subtracting, and move 1 over by subtracting, and rewrite it and combine it. So x squared minus 14x plus 48 now equals 0. Now, how could we factor this?
Thinking with the x.
So we're looking for what?
What's 549?
48. And what two numbers would work?
Negative 7 times 7.
Not 7 and 7. Negative 6 and negative 8. So x minus 6 and x minus 8. Set both equal to 0. What would our solutions be? 6 and 8. For 21, we would do the same thing. But when we move 28x over, we're not actually combining it with anything because it doesn't have anything to combine with. We're just moving it over. So when I subtract it, I'm not actually subtracting it. Subtracting these two, I'm just moving it over. So I could rewrite it. How could we factor this? And 4 leaving set both factors equal to 0 and solve. What would our solutions be?
0 and 7.
0 and 7. I meant to ask this after 20. But on both of those, what questions do we have on either of those? We're going to move on to the next page. Does anyone still need this? We're going to do example 2 and 4. For example 2, how could we factor this? Let's see. It is a trinomial. Say that one more time.
Could you divide it by? Oh wait, no, you're doing the.
You could divide by 5.
Yeah.
And that will leave. So then, yes, we're still going to do the x. This is now a trinomial where our a value is 1. So we're looking for what? The two numbers would multiply to be negative 12, but add to be negative 4. Negative 6 and positive 2 will work. When you do this, make sure you keep bringing down your DCF. X minus 6, x plus 2. Set your factors equal to 0. In this case, you would not set 5 equal to 0 because it doesn't have an x. If you did that, they wouldn't be equal. So that one doesn't have a solution. So we just look at the x parts. So what would our solutions be? 6 and negative 6 and negative 2. If it had 5x, that would be different because then we could solve it. But if it's just a number, we just leave it off.
Of everything?
Question on example 2. We're going to do example 4 and then move on to one other. I'm going to show you in desmos and then something else. For number 4, how would we start factoring this? Mm-hmm. And what are we looking for? So not multiply to be 5. 8 times 5. It has to be negative. So this one has something in front of x squared, so we can't ignore that. So two numbers that multiply to be 40 but add to be negative 22. They would both need to be negative. Negative 20 and negative 2. Because we have something in front of x squared, we can't just go directly into the factors as we were doing. This one we have to rewrite. 8x squared minus 20x minus 2x plus 5 equals 0. And then do our grouping. What do the first two have in common?
4, 8, and
4, not 8, and x. And what would be left?
Right.
2x minus 4, 5. And what could we divide out of the last two? And what negative ones, because this is negative. Which would leave us with 2x minus 5. What would our two factors be? 4x minus 1, 2x minus 5. Make sure this is still equal to 0. Now we're going to set both factors equal to 0 and we'll have to solve both.
That was a lot.
Sometimes you will end up with two fractions.
That's gonna be hard.
This delightful.
So we would have 1/4 and 5/4.
I decided to just create this.
You guys just had the same thought.
I hope there's suffering in life right now.
I don't know.
They're probably dead.
Probably good.
I hope they suffered when they were alive.
I make smart decisions.
No one uses this in
They're
their
probably down below.
other than maybe
Like,
finance.
how was this used?
Engineers
Did you
maybe, I
know
don't
it's
know.
actually really hard to become a scientist?
Huh?
Yeah. Just like know about.
Before we move on, do we have any questions on that one?
I don't want to ask any questions. Then I was gonna confuse.
Okay. For any of these problems, solve set equal to 0 or not. So I'm going to pick 11, and I'm going to put that one in Desmos and show you how Desmos would do this. Someone read off number 11 to me.
6x squared minus x equals 0.
Square minus
That's the other side. Equals negative.
Well, you can set that.
I did.
Oh, my bad.
Wait, it's on this page, correct?
This will graph this for you. Because we're looking for solutions, we're looking for what is across the x-axis. 0. You would need to convert that to a fraction. So -2 and -1/3 would be our answers.
Right there?
Yeah.
Are we gonna be able to do this for
The SOL, yes.
Thank
You will
God.
have,
Wait, can you show me how to do that?
I'm so glad
you will have
born into this
you will have
generation.
Desmos on the SOL on the test now.
For all of the parts?
I know that's answers, but you would have to put in different brackets. If you
Wait,
didn't know, hold on. If you didn't know what that was, you would need to factor it and solve it and figure that out. Or put in random fractions and see, does that work? So it's a repeating 3 decimals, so it has to be something over 3. So let's say I put in 3, and that would match.
But you should have negative.
Is the answer not negative 2?
Yes, that's what I was. That's why I was going back.
So you have to flip it.
They're not important to country.
Oh.
So it's not only in that, that's what we're taking.
Okay,
Yeah.
really quickly, on this page. This is like doing the opposite of what we're just doing, so I want you to go through this really quickly, and then we'll do some principal reviews. So for this is giving you the quadratic already. So you have to find the solution, be able to write that solution in factor form, and then find the equation. I know this graph is a little hard to see, but to the best of your ability, what are the solutions for number 3?
Negative 3.
Negative 3, and I think that's negative 8. So if we are writing that as factor forms, they're going to be opposite. How would we write that as a factor? X plus 8. X plus 8. And
X minus or
X plus 3. Whatever it is, it's opposite.
That's
Just like
it.
what we were doing.
No.
That's it.
Oh, of course.
There's another line instead of zero.
We now need to multiply these out and find their equation. X times X gives us what? X times 3 gives us what? 3x. 8 times X. And 8 times 3.
Something.
24. And then combine your like terms. X squared plus 11x plus. So yes, that's it. So that would be the equation of this quadratic. So if we took that equation and factored it, we would get these factors and then solved it, and you'd get these solutions. Everything's connected.
I don't know why I thought this was a good idea.
I agree.
Right.
I've seen bigger graphs.
You'll be able to see them clearly on that small. It's just printed here.
Okay, those dots are not.
Alright, what are the solutions to number 4?
X equals 5.
Numbers.
Negative 1 is 1 and 5 is 1, yes. So what would those factors be?
X plus 1 and X minus 5.
Correct. Write those down.
And then you do. 1x. And then.
Well, how did you get them opposite?
Yes, I am. What?
So as you start doing, check your answer with mine.
No, we got no one. I think we all do.
Whoever created
Yeah,
this.
it's way negative 5. That's the number 5. Do we have any questions on that? Oh, smoked it.
Please have a big cup because I have to eat these somewhere. I don't see
I literally got 122 pages on that
It's not.
That's what that's why I don't go back to elementary school. I don't want to be here. I was
Why is this good? Why is it fixed? They put on this.
I think it's very much good. Bring back the nap time.
Alright, let me get your attention. Okay. So one, you will get some formula sheet embedded in your SOL that'll look something similar to this. You may not need it, but it will be there for your reference.
Wait, so we can use this like on the SOL?
No, I'm talking about this sheet that looks like this. It will be in your test already.
Oh, it's already the formula.
Yes.
Wait, so do you remember when we took the SOL test? Yeah.
That's this.
The one that was
That's this.
Wait, just to be sure, so A is
This is the pre-SOL. Yeah, when did we take it?
ABC, Margaret said that.
Wow. Oh my god.
Alright, so I'm going to show you desmos tricks for as many of these as I can. For number one, that is an evaluating problem. So you would need to know that evaluating means putting numbers in, figuring out what that is. So you could use desmos to do that, and it will tell you what the answer is. To quickly put in cube roots and square roots, you can type in the letters SQRT or CBRT. That will give you cube root, square root. It'll like change it. There is a square root button, and if you go into functions and scroll all the way down, there is a cube root button also.
Guys, stop talking.
Wait, are we going through this?
The math SOL will have desmos. The other SOLs will not. We're going through as many as we can in this time frame. What was your other question?
Is all parts of the math and going to have decimals only like some parts?
You should have access to it the entire time.
That's just cheating.
Not to my knowledge.
Or in every single problem.
That means I don't know for certain. Don't take that as it should be or should not be. I do not know. So the answer to number one is 35. For number two, so
Wait, I'll get parentheses.
nope. For number two, this is really something you would need to know because unless if you happen to have two that are similar, this may not work. So this is a way to check yourself, but you would need to remember how to do this. So I am going to show you. If you put in your whatever this is, expression, it's not going to do anything. You would have to actually do it by hand in order to do that. However, if you change the variables to something that is not X, Y, Z, E, something else, you could use A, B, and C, but I'm using that for something else. That's why I'm using D. So if I change those to D, it's going to ask you for a slider. I don't know if I can do that right now. But if you put in a different variable, it'll say add slider D. Run it. Now I don't know how many of these functions are available on testing SOL, but let's assume it's there. Then it'll give you some slider where you can change the value of D. Make it so it's not 1, because 1 and 2 really could be the same, could not be. So make it something else. And then put in all of your answer choices so that it also has the same variable and see which decimal matches.
So
So 5 over x to the 18. Now again, you would need to remember to do all of that, or you would have to just do it. So multiply your exponents together. Some of these you could eliminate, like 15 over 3 is 5, so it couldn't be A or B. And then when you are subtracting your exponents, make sure you're being careful. Do we have other questions on 2? For 3, this is one we've talked about before, but I'm going to show again. So this is a quotient problem where you put in your what's given. Now, you would have to rewrite it because right now it's written horizontally in your paper. You need to write it as a fraction and put in all of your answer choices. A couple of them you could eliminate because if you have something that's squared and you're dividing by something that's linear, you're not going to end up with something that's cubed. So we can get rid of that answer. Same thing with this one. If we're dividing something that's squared by something that's linear, we're not going to still have a square. So it would have to be something that's linear. And when we look at this,
Wait, what is linear?
say that one more time.
What is linear?
A line.
Yes. Isn't it on the line?
We're looking for these would go through the axis, but they should be this. Oh, no, because I'm looking at multiple things. Something else is graph, that's why it's doing that. Okay. So if I'm looking at these black lines, or these black dots, I'm looking at which of these overlap. And the red one does. That would be my answer.
How would you solve it?
You would need to solve it, you would need to factor the numerator, find the factors that are the same, and cancel. So all of these can be solved, but you also have desmos that you could use as well.
So what's the answer?
So the answer is 5x minus 6.
Oh, so
If you need to change how it looks, you can go into the gear wheel, click on this, and it'll let you change the type of line and the color. There we go. That's why that was there. For number 4, it's talking about factors. So you could factor that completely and see which one matches algebraically. It is. Let's see which one. So we're gonna eliminate some of them. So this one, the red dotted, is your original. That's your quadratic. Anything that is not completely factored, so like 3x minus 15, 9x plus 6, those are not prime factors. We could still factor something else, so we can get rid of those. Because those would not be answers. Anything that is just a number by itself could not be a factor, just like when we were solving or finding our solutions and we had like 5 on the outside, we could set that equal to a 0. So those would also not be factors. So that gets rid of some. Now we're looking at which of these are our answers. We need 1, 2, or 0, because those are the amount of factors or solutions we can have. This crosses the x-axis twice, so we're going to have 2 answers. And we're looking for which of these lines cross the x-axis at the solution points. Black and blue.
Oh, is it gonna be opposites?
So those 2 lines where it crosses your x-axis or your solution points would be your answers. If we were to solve both of these, we would get the solutions that are on there. So those would be your answers.
So from most of these, you just put the actual equation and the answers.
A lot of them you can. Some of them you have to know how to do, but a lot of them you can.
So you just gotta be able to put them all on the graph and get the correct answer. It's just like
Basically. Now there are some that's not the case where you actually have to do work, but a lot of them you can do without doing a lot of work.
well, a lot of them use that. Some people probably pass or just do the calculus.
Also,
Oh, I love this.
So, and the levels.
number 5. We'll just do a few more of these in the top. Same thing I said before, you can put in different variables that are not x and y and see if the numbers match. So here I have I and L as my variables instead. Change them to something that's not one, both of them, doesn't matter what they are, and look for which ones match. So we're looking for 3.60 something. No.
Wait, so even if you change like the amount that the variable is, it doesn't matter.
Because really what it's doing is it put in some number for that, it like evaluated it at some number. So whatever these are should be the same. It's like when we just had some square root or some cube root and we had just a number and the decimals were the same. That's like the same thing. So 3, I think I put these in here, but 3x to the 4th y to the 8th 20 times the square root of 20x, that answer, B.
So you just put in all the questions, and whichever one is to whatever.
You have to put it in with different variables though. If you put it in with x and y, it's not going to do anything for you.
Oh, that's
So you may get that problem, put it in, and forget that you have to change the decimals, and then in that case, I would just solve it.
If you change it to I and L.
Yeah, you can change it to really anything. I have a bunch of variables in all these ones, so I can use the same thing for all of them. It gets weird. But you could have just changed it to A and B, that would be fine. Number 6 is just a cube root, so these you can put all in without any variables and see which decimal match. So 15.1, it's B again. Yep. Now be careful with these because they like to put 2 of the same decimals. So if you get something like that, one of them is probably not simplified, and you need to simplify it further. In this case, they didn't do that. Wrong, didn't. It's not B because this can be simplified. It's the cube root of 16 can be simplified to 8 and 2.
Oh.
So it's C, not B.
So you just have to find whichever one is simplest.
Simplest, yeah. So same decimals and simplest.
So you gotta make sure that the ones that we keep
Correct. Or whatever root it is. Square or cube. Question on 6?
Very good.
On 7, you could put each of the answers in for the cube root and see which one gives you. So once you to get this answer, and you can put each number in and see which one matches. And there's only one that matches. So I put the original 5 times the cube root of 7, and then I put the cube root of each number and saw which one matched.
So it should be answers with values of that.
Wait, what question?
7. Say that question again.
All the answers are values of x.
Yeah, it's because it's asking which value of x. So yeah, there are different values of x. Yes. No.
So you have to put the decimal in to see which one.
If you put them all. 8, if you were to put, say that again.
Which letter is that?
C. 8 you could put into desmos, but you would be trying a bunch of different combinations to see which ones match. That one I would say just do. Multiply 4 and 2 to get 8, and then multiply 2 and 3 to get 6. If it could be simplified, make sure you simplify it, but this one would not need to be simplified. This is a drag and drop question, so you would drag these numbers to these levels. Number 9 is something you would need to know. That's not something Desmos can help you with. If they solve something and the last line was 1 equals 2, what would the answer be?
No solution?
No solution, because those are not equal numbers. That's something you need to know. If it was 1 equals 1, what would that be?
Well, I mean, the main is
Infinitely many. Say that again. Yeah. Okay. Number 10, we've been talking about solutions, but that's something you could do in Desmos. And then I think we'll do 11, 12 real fast because that's just me showing you that. So for 10, you put that into Desmos. This is really simple. This is a U shape, it's just brittle. But you would look for the solutions where they cross the x-axis.
And that would be your answer.
And that would be your answer. Now they give you fractions, so you would need to see which one matches, yeah. Negative to C, yeah. You could also put this in -3/2 and convert it to a fraction or a decimal. Put in the fraction, use this button right here to see if it's the same fraction or decimal. For questions like 11, where you have equations or inequalities, if you put it in inequalities, it'll graph it for you.
You would see it.
So this would be greater than, find the solution where it crosses the x-axis, that'll give you the point. And you will need to know dash line is just greater than, so x is greater than -9 would be your answer. X is greater than -9 would be your answer for 11. If it was on the left, it'd be less than. If it was a solid line, it'd be greater than or equal to or less than. And then 12, you can do the same thing. So 12 is a drag and drop, so you would have to drag the correct ray. So I'll draw that on here so you have it in the video if anyone goes back. But this would tell you this is going to be a less than or not equal to, just less than, at -4.
So it's going to the left.
So it's going to the left.
Wait, x is greater than.
It would have an open circle, yeah.
Is x greater than -9 or just
I think that one was. It was -9.
Oh, okay.
Bella? I don't know for certain. I'm gonna say maybe a little more than what's on this. Maybe.